So what does caffeine do? Well, caffeine is an interesting drug, and the mechanism is still being worked out to some extent. But we do know that there's a particular receptor, and the last thing you probably want at this stage in the class is the introduction of a new receptor. But there's a receptor called the adenosine receptor. And adenosine is a chemical compound that's associated with ATP, for example, right? Adenosine triphosphate, which is the kind of energy molecule in the cell. Right? It's always being broken down to, move transporters to transport something from one side to the other, of a membrane, for example. And adenosine levels actually, it turns out, rise in your bloodstream throughout the day. So as you, continue your activities and you use energy, et cetera, there's going to be this rising level of adenosine circulating in the blood. And it's thought that adenosine may be one of these kind of, blood-borne markers for fatigue. And when it reaches a certain level, you're going to start to feel tired. And the way it appears to, be linked to this effect is that adenosine typically will bind to adenosine receptors, right? And it's a metabotropic receptor, right? It's releasing a G protein. But the result will be to reduce activity, to slow down the release of dopamine, to slow down the release of norepinephrine, to slow down the release of serotonin, to slow down the release of acetylcholine. And as all of these systems, these systems start to reduce their level of activity, you start to feel drowsy, you start to get tired, you start to sort of fade out, right? So caffeine blocks these receptors. It prevents adenosine circulating in the blood from binding to its receptors and slowing down the release of monoamines and acetylcholine. So it's thought that by blocking these adenosine receptors, you still are fatigued. You still have signals in the blood that are trying to signal your central nervous system to slow down, right? But you're no longer listening to those signals, right? You're sort of blocking them out because caffeine is an antagonist at this receptor.